U prošloj emisiji smo vam predstavili tim istraživača profesora Staniše Raspopovića sa ETH u Cirihu, koji ljudima sa amputiranom nogom uz pomoć električnih stimulacija omogućava da proteze osjećaju kao deo svog tela. Iz laboratorije za neuroinženjering u Cirihu otišli smo u laboratoriju za neuroinženjering u Lozani. Na EPFL-u smo saznali o najnovijim projektima kolaboracije robota i čoveka namenjenih hiruškim salama i industrijskim postrojenjima. Na kraju smo vas upoznali sa profesorom Aleksandrom Antanasijevićem, čiji istraživački tim radi na dizajniranju univerzalnog protivotrova od ujeda zmija, vakcina protiv HIV-a i drugih zaraznih bolesti.
Švajcarska ima 2 federalna instituta za tehnologiju, jedan u Cirihu, a drugi ovde u Lozani. Institute finansira država i oni daju snažan doprinos ekonomskom prosperitetu Švajcarske. To su centri, međunarodno priznati centri izvrsnosti za nauku, obrazovanje i inovacije u koji dolaze najbolji studenti i istraživači iz celog sveta.
Danas je potrebno ne samo vreme, već i dobra kondicija da biste prepešačili s jednog na drugi kraj EPFL-a, koji je pre više od 50 godina osnovan kao Švajcarski federalni tehnički institut i od tada se neprestano širi i dograđuje. Sa ekspanzivnim razvojem novih tehnologija i ultimativnim multidisciplinarnim pristupom rešavanju naučnih zagonetki, EPFL je prerastao u institut za tehnologiju sa vrlo širokim spektrom naučnih oblasti integrisanih u istraživanja koja probijaju granice poznatog i kreiraju inovacije.
Want the research that is conducted at EPFL to have an impact on society, and most of the time this impact comes through the development of startups or integrating into bigger companies. And for this we have a whole system of technology transfer, an office that helps everyone to file the patents, to make all the paperwork, and also to help to find the fundings to develop their products. So we have each year more than 20 startups that come out of EPFL. A huge number of projects, of course, that are going on. Maybe among the biggest ones, or the ones that make us known around the world, we are very active in energy research, hydrogen or solar power harvesting or hydropower. We have also one reference center in plasma physics, which is working towards the nuclear fusion.
Robotics is very important.
Robotics is also very, yes, it has been historical. Robotics has been historically an important part of EPFL research, but it's really also only a fraction of everything that is going on here.
Iako je samo deo velikog sistema kao što je EPFL, u laboratorijama za robotiku se oblikuje budućnost tehnologije kroz revolucionarne projekte. Primjer su takozvani robogami, roboti nastali po uzoru na tradicionalnu origami japansku veštinu kreiranja modela od papira. Koliko je ova zamisao inovativna i inspirativna, svedoči svetska popularnost kreatorke ove ideje, profesorke Jamie Pike, koja je robogami koncept prezentovala na TED-u.
A lot of robots get inspirations from origami. It's the art of folding papers. And just like the origami, our robots don't necessarily have a specific shape in the beginning. However, depending on its task, it can expand to different shapes that renders it to be more functional. So for example, in the beginning, all I had shown was paper airplanes or boats made out of a single sheet of origami, robotic origami platform. But now these origami platforms now are developed for space exploration tasks or transferring the sense of touch, like transferring softness or rigidity. And this type of robots are now getting to be interested for utilization in medical field as well as in industries for drawing different manipulative tasks.
This is Mori 3, modular origami. What we are trying to do is create transformers, robots which can change their own shape. These robots can perform different tasks, from walking, rolling like a tire, and behaving like a robotic arm, and so on and so forth. These robots are useful for things such as long-term space missions, where you don't know what challenges you will have ahead of time, and in the far future, just in your everyday home, as a multi-tool for whatever you need. So within each of these modules, they all have their own, they're their own complete robot. So if you look at the center, it actually has a brain as well as a microcontroller that controls its instincts. Right now, they talk together in order to create motion together. And we are leaving a lot of space on their brain, per se, so that eventually they can make their own decisions together and be able to decide how they want to move in order to perform a task. There's different elements which handle everything within here. They move backwards and forwards from internal motors, and they can expand and contract from other motors that are also inside. And they have to move together in order for this motion to happen. And so the ability to coordinate and to talk to each other is actually extraordinarily valuable and something that we spent a lot of time in trying to perfect in these robots.
When you look at our robots, they don't feel threatening. They don't feel as heavy duty as what you would imagine in your movies or what you see in the industries and factories. The reason is that we are taking advantage of this technological advancement of embedding all the core components of a robot into a single platform. So in our single platform robots, we have all the core components of what all the robots need. For example, batteries, electronics, microcontrollers, sensors, and motors. And that's where the scientific advancements happen. We try to put all of them embedded within the same platform. It's not only the advancements in terms of the hardware development, but also advancements of software development. How do you deal with this many components if it were to be a single module that are linked multiple ways and multiple agents? How do you make them communicate to each other? How do we use all the information they collect from the environment and put them together to make sense out of the world? So these are the types of technological advancements that we are studying at the lab.
Me and my colleague are trying to build a robotic surface with modular foldable origami robots. So we are trying, because right now most manipulation is done by the gripper or robotic hand. However, here we are trying to use a surface to manipulate object, because the hand is really challenging to handle the soft and deformable objects. However, we think the surface is more suitable for this case, because in the daily life, we are trying to use spoon to eat mashed potatoes. We are trying to use hand holding a slippery fish like this. However, it's really difficult for the gripper to do such a task. So here I'm trying to move this object to the target position with this single surface. So each time it will transfer this object to the target position. We think this technology can potentially be used in the food industry for the packaging line. So for example, to packaging the chicken or fish into a box. And the beyond and the pick and place, we also can use this technology to manipulate the shape of soft object. For example, we can combining two surfaces or multiple surfaces. There's a endless possibility for this technology. Yeah.
So my work here is trying to link the simulation and the reality to study on the dynamic recreation of soft surfaces. So we have already seen lots of products from Meta, from Apple regarding on VR devices. People is able to look and see something that they were never see or look before. And here we're trying to fill the missing part, which is how people feel. So in this device, we're able to recreate the soft stiffness of the surface in a dynamic way, so people is able to touch and feel in different surfaces made by different materials. And here is basically an example, like we're linking our simulation, which is fully functional dynamic simulation, and sending the data directly to our device to mimic exactly same behavior dynamically. So here in RL, we're all using this kind of origami-based structures as shown here. Basically, they're all individually controlled and drove in a way that we're able to generate this dynamic stiffness change.
So softness is very crucial for the survival of human beings and animals. So for example, when you are buying your mattress to sleep, you touch and you feel how soft it is. Or when you want to buy your avocado, you touch the avocado and you feel if it's ready to be eaten or not. So, but this feeling is very complex feeling. So when you touch an object, the cues of softness coming from actually two things. First is cutaneous, which means the skin level, and the other one is kinesthetic, which is coming from the finger joints. And we build a device, haptic device in this lab, that we can control these two cues and recreate the sense of softness. So, and here's the device. So this is called Sorry. So when you touch this object, we can create the softness of digital or actual objects. So there are many fields of application. So first of all, you can use this for online shopping. Let's say you want to buy an avocado on an online shop of your favorite, and you want to buy a specific avocado, but you want to feel if it's hard or soft, and then you can touch this device and you can feel the actual softness of the avocado. Second, with using this device, you can touch objects in the remote, which means, for example, you want to feel the softness of an object in space or in deep sea. So using this device, you can touch things that you cannot reach to. Third, you can touch digital objects, or in other words, you can be used in virtual reality or augmented reality. So you can create any kind of object in virtual reality, and by doing that, you can interact with the objects as well.
What origami robots and soft robots that we are developing in the lab is doing beyond what's been done before is that we are able to bring high level of technology that are much more agile than what we've known before in a very small scale and compact format. And also, these compact format robots can be customized to the users. And those users are not necessarily have to be engineers or roboticists, but these are the everyday person who's just looking for next adaptation, next automation of the platforms that they didn't even know they needed.
Digits is a modular haptic interface for virtual reality applications. And in virtual reality, you can see the virtual environment through your goggles, and you can hear the sounds from the virtual environment with your headphones. However, when it comes to interact and manipulate the objects in virtual environments, it's a bit of a challenge. And here we're developing a pneumatic-based modular haptic interface that consists of single modules like this, and by the application of air, it is possible to bend this structure. As a standalone module, it doesn't have too much functionality. However, when you combine them with different configurations, it is possible to come up with different haptic interfaces. For example, this one is a graspable haptic interface that is able to form different shapes and also different stiffnesses. And using the same modules in different configurations, you can also build a haptic interface that is wearable, and when you wear it and when you control the air inside of this device, you can render different stiffnesses to the user.
Imagine humans have more hands and arms. What else we could do? Definitely we could do more complex tasks. So in our lab, we developed an origami-inspired, modular, wearable robotic third arm. So this arm can be worn on different parts of human body and can help us to do more complex tasks. For example, let's say you are cooking and you are chopping your vegetables, and you need someone else to stir the food so that it doesn't get burned. So if you have a robotic third arm, which we did, so it can help you with your daily tasks. Or Another example, so you can put it on your back and you can reach to some places that you cannot reach, for example. And the modularity of the arm is super useful for the adapting to different daily tasks. So by basically adding extra modules, you can achieve a longer arm or shorter arm depending on the task that you need.
EPFL je poznat po otvorenosti za naučna istraživanja i po kosmopolitskom duhu. Danas sa nama je Mirjana Stojilović, koja je iz Beograda, je li tako? Vi ste završili elektrotehnički fakultet, doktorirali tamo, radili ste u institutu Mihajlo Pupin i onda ste došli na EPFL.
Jeste.
Zašto? Kako ste stigli ovde?
Pa eto, još u to vreme kada sam bila doktorant na elektrotehničkom fakultetu i kada sam se bavila projektovanjem namenskih računarskih sistema u institutu Mihajlo Pupin, ukazala mi se prilika da boravim na EPFL-u. To je bilo u okviru jednog bilateralnog projekta transfera znanja između EPFL-a i instituta Mihajlo Pupin, koji je još tada finansirala Švajcarska fondacija za nauku. I već tog prvog puta kada sam bila na EPFL-u u Lozani, zapao mi je za oko taj kosmopolitski duh i prosto kvalitet i obim naučnih dostignuća na EPFL-u.
Otvorenost za saradnju, za međunarodne timove, za istraživanja.
Jeste, tako je. I znate kako, baviti se naukom to zahteva kreativnosti, ali zahteva i odličnih studenata iz celog sveta i novčane resurse, čega na EPFL-u imamo.
Vi ste i naučnik, istraživač s jedne strane, ali i predavač.
Jeste.
Tako da možete da uporedite i te dve stvari. Kako to prvo postižete i kako je ovde organizovan taj i obrazovni deo i istraživački?
Ja evo već 10 godina predajem na osnovnim studijama i moje predmete pohađa pa više od 800 studenta svake godine, što je veliki izazov jer svi studenti uče na neki svoj način. Predavači generalno imaju dosta izazova u svom poslu jer mi moramo spremiti kako sadržajem, tako i vizuelno kvalitetan materijal, a moramo ga i preneti studentima na neki interesantan, jasan način, tako da oni i nauče i povežu to znanje i kasnije ga primene u praksi.
EPFL dosta ulaže u taj obrazovni deo. Šta je to inovativno u samoj nastavi?
Mi dosta imamo i pratimo inovacije, ali imamo neke inovacije koje dolaze iznutra. Imamo grupe istraživača i na mom fakultetu za informatiku koje se bave recimo kako mi možemo koristiti tehnologiju veštačke inteligencije da nam pomogne da vidimo u čemu se studenti muče u toku same nastave, koji su to teme koje su im teže, pa da se onda više posvetimo tim temama. Pored toga, naravno, ima i tih klasičnih nekih povratnih informacija od studenta koji preko ovih anonimnih anketa ocenjuju kvalitet nastave svakog predmeta. To je nešto što i ja dan danas koristim da prosto unapredim svoju tehniku predavanja da bi ipak moji studenti bili zadovoljni.
Trenutno na EPFL-u ima oko 15.000 studenta, od kojih je 60-ak iz Srbije na doktorskim i postdoktorskim studijama. Bojana iz Loznice kroz osmeh kaže da je Lozana dovoljno slično zvučala da bi se ovde osjećala kao kod kuće, dok je Mirjana kao doktorant sa FTN u Novom Sadu prešla u Švajcarsku jer je program bio ostvarenje svih njenih želja.
Ja sam studirala paralelno na 2 fakulteta. Završila sam informatiku na FON-u i računarske nauke na računarskom fakultetu. Tu sam imala stipendiju, pošto sam bila đak generacije računarske gimnazije tamo. I da, zanimljivo je što se sad bavim zapravo hemijom. Sad sam na doktoratu u oblasti hemije i hemijskog inženjerstva, ali je laboratorija koja se bavi zapravo primenom mašinskog učenja i te veštačke inteligencije u hemiji, tako da ja primenjujem to svoje znanje koje sam sticala tokom osnovnih i mastera, a sad na doktoratu.
Definitivno je da se ovde više investira u nauku, u naučnom smislu i ovde imamo pristup naučnicima iz raznih dijelova sveta i ovde imamo pristup podacima kojima ja ne bih mogla da pristupam u Srbiji i nekako mislim da sa tog stanovišta resursa ovde su stvari bolje i nekako ja, pošto sam krenula doktorat u Srbiji, mislim da mi u Srbiji nismo toliko vidljivi. Na primjer, moja master teza je bila napisana na srpskom, dok, na primjer, ovde studenti sve rade na engleskom. Ja mislim da je to prva promena, na primjer, koja bi mogla da se uvede na srpskim univerzitetima. Druga stvar što se meni ovde više dopada u tom nekom smislu podučavanja jeste da ovde studenti već na bachelor nivou, znači na osnovnim studijama već oni imaju kontakt sa laboratorijama gde oni sarađuju sa naučnicima koji rade na realnim problemima. I njima su dostupni i svi ti podaci i svi ti serveri i jednostavno oni su već uključeni u rad kako to funkcioniše u stvarnom svetu. Dok u Srbiji nekako mislim da mi smo više bili fokusirani na to da ponavljamo neke činjenice umesto da se fokusiramo na rešavanje problema. Naprimjer, ovde studenti, oni koriste puškice na ispitu i to je sasvim dozvoljeno, zato što na kraju krajeva ne ocenjujemo mi to da li ćeš ti da zapamtiš nešto, pogotovo sad sa prisustvom chat GPT-a i tako dalje. Moramo i mi malo da se, što se nekako kaže, updateujemo, da malo obnavljamo sve te naše materijale. Tako da mislim da to u Srbiji malo kaska, a ovde su ljudi u skladu sa vremenom. Oni konstantno rade na sebi i moraju konstantno da objavljuju radove da bi ostali na toj poziciji gde su, jednostavno moraju da budu kompetativni i da se konstantno usavršavaju.
Evo nas u obrazovnom centru Rolex, prostoru koji je namenjen isključivo studentima, gde imamo biblioteku, gde ima puno prostora gde oni mogu da uče. Ali ispostavlja se da to nije dovoljno, zato što već godinama unazad broj studenta se povećava. I ono što je interesantno na EPFL-u i u Švajcarskoj generalno, jeste da se ovde sve planira dosta unapred. Tako da se već sad zna da će se kroz 4 godine izgraditi, ovde pored samog centra Rolex, jedan potpuno novi kompleks namenjen isključivo nastavi, koji će omogućiti EPFL-u prosto da primi sve te studente i bit će zaista puno novih mesta i radujemo se svi tome.
Dr. Mirjana Stojilović kreira budućnost u oblasti dizajniranja servera. U laboratoriji za arhitekturu paralelnih sistema radi na računarskim jedinicama čiji se hardver može rekonfigurisati da obavlja bilo koju funkciju.
Moji doktoranti i ja se fokusiramo na jednu posebnu vrstu računarskih jedinica koje se mogu programirati ne na softverskom nivou, već na nivou logičkih kola u samom čipu, pa se na taj način specijaliziraju za praktično bezbroj korisničkih primjena. Ta takozvana programabilna logika ili stručno rečeno FPGA je sve zastupljenija u modernim data centrima zato što prosto za veliki broj aplikacija može da da bolje performanse nego što to procesori ili pak grafičke jedinice mogu. Moja grupa je jedna od prvih i vodećih na polju otkrivanja, analize i otklanjanja rizika za korisnike data centara od tih hakerskih napada u kojima hakeri mogu da prosto zaobiđu neke postojeće mehanizme zaštite i dođu u neovlašćeni pristup ličnih podataka tih korisnika. Rezultati naših istraživanja su omogućili kompanijama kao što recimo Amazon da unaprede svoje sigurnosne procedure i zaštite svoje korisnike.
My research primarily focuses on accelerating the verification process of these large chips using FPGAs. Our tools made to speed up verification are already being followed up by large companies such as AMD. They are looking at our tools, the architectural enhancement that we propose, and this shows that the research that we are doing at EPFL under the supervision is creating impact not just in academia but in the industry as well.
Jedan od velikih izazova u savremenoj eri digitalizacije i sve veće upotrebe veštačke inteligencije je potrošnja električne energije i posledično negativan uticaj na životnu sredinu. Institut u Lozani je jedan od pionira u sagledavanju i rešavanju ovog gorućeg problema.
Data centers are now roughly about 4% of electricity consumption in Switzerland in the modern world. They're also growing in electricity consumption at 5% a year. And so what we need to think about is what are proper ways of precisely quantifying this electricity consumption and work on technologies to make sure that they do not surpass the advantages we get from information technology. I'm the founding president of a nonprofit in Switzerland called the Swiss Data Center Efficiency Association. We have launched a certification for efficiency and emissions in data centers, which not only looks at the infrastructure for hosting information technology, but also the infrastructure that is used for computation, including the servers, network, and storage. And this precise measurement will give the customers and the users of information technology a bit of idea as to how well they're using electricity.
Izgradnja eksperimentalnog data centra u kampusu EPFL-a je u završnoj fazi. U njemu će biti testirani novi koncepti ekološke samoodrživosti.
What are we doing in this experimental data center is we're looking at technologies from the highest level of abstraction inside the computing stack, which is algorithms, from algorithms all the way down to cooling, electrical distribution, recycling of heat, the entire energy flow. We're re-examining this and we're co-designing these technologies together to bring the efficiency that we don't have because Moore's law has stopped.
EPFL je primer kako uspešno organizovati sistem u kome se razvija vrhunska nauka i gde stasavaju nove generacije istraživača koji će svojim inovacijama promeniti svet.
Nadam se da ste zajedno sa naučnicima iz instituta u Lozani zakoračili u budućnost. Budite sa nama i sledećeg puta, na sledećem putovanju. Gledajte Vodič kroz budućnost.